Selenium for Beginners with Rex Jones II.
Hello and welcome to Selenium for Beginners. We are going to discuss how the Selenium architecture works for automation. The transcript and presentation slides will be available on GitHub at rexjones2nd/Selenium for Beginners and tinyurl.com Selenium Architecture. In this lesson, I will show you a diagram of the Selenium architecture, demo the Selenium architecture components, then recap the Selenium architecture. The architecture of Selenium WebDriver is mainly about communication between the client and server. There are 4 components that make up the architecture. The first component is Selenium Client and WebDriver language bindings. Next is the JSON Wire Protocol. Third, we have the browser drivers. And the fourth are the web browsers. The first component has 2 parts. Selenium Client is one part, and WebDriver language bindings is the other part. Selenium Client is responsible for sending out a request to perform a Selenium command. The WebDriver language bindings is a code library. A good way to think about a code library is to imagine a library with a lot of books. Rather than having books, a code library has a lot of code for Java, C#, Ruby, Python, and JavaScript. There are more programming languages that can be used for Selenium, but these are the 5 core languages. Each language has their own bindings. Bindings mean the same commands written for Java is also written for C#, Ruby, Python, and JavaScript. For example, Java has a command for navigating to a page, and the other languages have a command for navigating to a page. Let's take a look at Selenium's HQ website. We see the Selenium WebDriver API commands and operations. API stands for Application Programming Interface, which allow communication between applications. All of these languages have a command for navigating to a page, but Java, Ruby, Python, Perl, and JavaScript use get as their method. Here's the method for C#. We can download the Selenium Client and WebDriver bindings from their website. After downloading the APIs for Selenium, we can add them to our IDE, such as Eclipse, NetBeans, IntelliJ, or Visual Studio. If we scroll down to the third-party drivers section, we see our next component, which is browser drivers. Gecko driver, chromedriver, Opera, Edge driver, and Safari driver are some of the drivers. In this diagram, the browser drivers have 2 functions. The first function is to receive a request, and the second function is to return a response. Both of these components illustrate a client server model. What is a client-server model? A client-server model is when the client makes a request and the server executes that request. After executing that request, the server sends back a response to complete their connection. Their connection is built around a JSON Wire Protocol over HTTP. JSON stands for JavaScript Object Notation, and HTTP stands for Hypertext Transfer Protocol. The objective of a JSON Wire Protocol is to transfer information from the client to the server. That information is processed over HTTP by sending HTTP requests and receiving HTTP responses. Let's take a look at the JSON Wire Protocol on GitHub. The introduction states this wire protocol defines a RESTful web service. REST is an acronym for Representational State Transfer, and it is used to create APIs for a web application. Recall, Selenium is an API. Therefore, the JSON Wire Protocol has an API call for every Selenium command. If we go to the command reference, we see a column for HTTP method, path, and summary. The command summary lists 3 of 5 HTTP methods: get, post, and delete. The methods put and patch are not here in this command summary. We see a path and summary for timeouts, implicit wait, navigate to a new URL, frame, get the current page title. We also see something for click on an element. We see a get HTTP method request and a session API call. Session ID is the URL parameter. It's an ID of the session to route the command to. The page title is returned as a string. Let's go back to our diagram and review the flow. A Selenium request is sent from the Selenium Client and WebDriver language bindings components. That request is sent to the JSON Wire Protocol, which defines a REST API. The REST API is sent to the browser drivers in the form of a URL. Chrome driver, Firefox driver, Safari driver, Opera driver, and Edge driver all have their own HTTP server. Finally, we have our last component, which is the web browsers. All Selenium commands are performed on the web browser. Notice there is a 2-directional arrow between the browser drivers and web browsers. This is one of the reasons why Selenium executes our test script so fast. The browser drivers receive a request, and immediately the web browser executes that request. Whether our test script passed or failed, the web browser returns a response back to the browser driver. The browser driver sends that same response back to the JSON Wire Protocol and eventually to the client. If the action fails, then an exception shows up in our IDE. I am going to use Java as the programming language and Eclipse as the IDE. We start by downloading Selenium from Selenium HQ website to my download folder. Then add Selenium to Eclipse Libraries tab as external jars. JAR stands for Java Archive, which allows us to write our Selenium commands using Java. WebDriver driver equals new chromedriver. Chromedriver is our browser driver. Next is system.setProperty. The key is WebDriver.chrome.driver. Value is the path of chromedriver. Now we load the wire protocol page using driver.get. Then get the title using driver.getTitle. Know what? Let's also print the title. And run. The page landed on get the current page title. Eclipse shows JSON Wire Protocol, which is the page title, and our test script passed. Let's recap the Selenium architecture using our test script. With the first component, we wrote our Selenium commands using Java. A request was sent to set up chromedriver, load the web page, and print the page title. The JSON Wire Protocol received the request, then changed that request to a format so chromedriver can understand the command. Chromedriver sent a direct HTTP request to the Chrome web browser. The Chrome browser performed each command, then sent back an HTTP response to the Chrome driver that eventually showed up in Eclipse. I hope that helps, and thank you for watching how the Selenium architecture works for automation.
Online courses coming soon. Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.